Bill Blodgett. I'm Bill Blodgett, president of the Sun City Nature Club. And our speaker today is Dr. George Biggs. His topic is Texas native plants and animals, their effects on climate change. A little bit about our speaker, Dr. George Diggs. George Diggs is an evolutionary biologist and botanist who has taught for 40 years at Austin College and in Sherman, and is a research associate at the Botanical Research Institute of Texas. His research interests include the plants of Texas, evolution as it relates to human health, climate change, and biogeography. Another area of his research is on evolution in extreme environments, including tropical rainforests, high mountain peaks, deserts, Antarctica, and the Arctic. In his research, Dr. Diggs has traveled to all 7 continents and has taken students on research trips to 15 different countries. He has interacted with traditional diet peoples from Greenland to South America and Africa. Dr. Diggs has co-authored 4 books and more than 30 scientific articles. His latest books are The Hunter-Gatherer Within, Health and the Natural Human Diet, co-authored with Dr. Carrie Brock, and The Ferns and Lycophytes of Texas, co-authored with Barney Lipscomb. In 1999, he was named Texas Professor of the Year by the Carnegie Foundation for the Advancement of Teaching and the Council for the Advancement and Support of Education. He has received other awards for his teaching. Dr. Diggs received his BS and MA from the College of William and Mary and his PhD from the University of Wisconsin-Madison. Please join me in welcoming Dr. Diggs.
Thank you, Bill. I hope you guys can see the PowerPoint I've just put up. Somebody nod. Bill, nod if you see. Okay, great. All right, so my topic today, as Bill noted, is Texas native plants and climate change. And so here's an overview of what I'm going to be sharing with you. I want to talk briefly about the evidence, some personal observations from various research trips I've done, and also focusing on the effects of climate change on plants, animals, and ecosystems, particularly those here in the state of Texas. So I'm not going to talk hardly at all about climate change in general. I assume all of you are aware of the broad strokes of this, the gases that humans are releasing, and these gases are trapping heat in the atmosphere, carbon dioxide being the big player. Now, I'm a scientist, and I'm interested in data and evidence. People have all kinds of feelings, and they'll tell you what they think about climate change. That's not particularly of interest to me as a scientist. What I want to see is the evidence. What does the evidence say? And so you might be wondering, why am I showing you a picture of the Mauna Loa Observatory? This is on top of one of the tallest volcanoes in Hawaii. And the reason is that's where we have some long-term atmospheric evidence. What is actually happening to the Earth's atmosphere. So the reason Hawaii was chosen for this long-term study is that it's out in the middle of the Pacific, and so it's not really affected by local pollution very much. So what you're seeing is what has happened to the atmosphere of the Earth, okay? And this study was begun in 1958, and it's been continued ever since. And basically, there are atmospheric readings been taken every year since 1958. And in particular, we're interested in what's called the Keeling curve, and that is the amount of CO2 in the atmosphere. Okay, so the amount of carbon dioxide, and notice that from 1958 until now, every year CO2 has gone up and up and up and up and up and up and up. It's been a relentless climb. And you might be wondering, okay, it looks like it seesaws. And that's true because this is in the northern hemisphere, and during the winter, plants are not taking in very much CO2. Or sorry, they're not giving off very much CO2. Okay, let me back up. It's a little more complicated. Plants both take up and give off CO2. Okay, so they respire just like we do. But in the summer, they're giving off some CO2, but they're taking in a lot more. And so every summer, this curve goes down, and then in the winter, it goes right back up. So what you're talking about is the balance of CO2. And so this has been a relentless climb. And scientists have been making predictions about what's going to happen as a result of this, because this has been a pretty dramatic increase, going from a concentration here in these units of 310 now up to close to 420. That's a very large increase when you're talking about a planetary scale. So this year we're well over 400 parts per million, and it hasn't been this high for 3 million years, and that's long before our species existed. And it's called the Keeling curve because of this man, Charles Keeling. Now, as I say, scientists make predictions. And so one thing they predict is if there are more heat trapping gases in the atmosphere, prediction is that on average, global temperatures will increase. And scientists also predict that there will be various changes, other changes in climate, including more extreme weather events. Okay, so what is the evidence? What do we actually find? Well, if we look over, beginning in the late 1800s, 1880, this is the data over that period of time. Now you might wonder, why did we start in 1880? And that's because there were enough thermometers then worldwide that we think the data is reasonably accurate. And the global temperature is complicated because global climate is complicated. And you've got two things you see. You see little black dots there each yearly, each year's temperature. And then you've got the red, which is this is called lowness smoothing, which is a way of smoothing out that line, but trying to accurately get one line in there. And you notice that after World War II, things began to kind of go up and up and up and up fairly steadily. And we don't think this is accidental. Global temperatures, it's gotten pretty dramatic, and it's becoming now a problem. So scientists are predicting, in fact, we've been predicting since sometime in the 80s that, this has become widely known since sometime in the 80s. And we keep seeing this trend. Now, other people say, well, it's a natural phenomena. This is not caused by humans, but we're seeing exactly what we predict. For example, and I've been teaching about this for a long time, 2015 was the hottest year on record. Then 2016 was the hottest year on record. Then 2017 was the third warmest. 2018 was the fourth warmest. 2019 was the second hottest ever. 2020, it's not quite clear because there are a number of groups measuring temperature. 2020 is either tied for the warmest year or just a tiny bit below 2016. So the evidence is pretty clear. It's very hot. And if we look at this in more detail, the past 7 years are the hottest on record. So this could be an accident. But boy, it doesn't seem likely that that would be the case. What is the probability? And scientists are looking for what is the most likely conclusion we can have based on the evidence. And by the way, 2011 to 2020 was the warmest decade ever known. Now, so clearly this is happening. Now, there might be somebody that says this is not happening, but it seems virtually inconceivable that there is a multinational conspiracy to do this, because all kinds of countries are getting the same kind of data. So when you say, is it natural? I want to look at the rate of change. And according to NASA, the current warming is occurring roughly 10 times faster than the average rate of ice age recovery warming. In other words, at the end of ice ages, how fast did it warm up? Well, the current warming is occurring roughly 10 times that fast. That rate is not natural. There is a human signature in this. There are other reasons to conclude that, but I think for this talk, that's one that I think will get your attention. Now, I don't really like to call it global warming. I like to call it global climate change. And the reason is that the predictions include a lot more than temperature. The predictions include more extreme weather events. And indeed, we are seeing many more extreme weather events. I don't think I have to tell any of you guys, if you're at this talk, you're probably pretty tuned into news, and just this summer, it's been pretty dramatic. Now, it's difficult to blame any particular weather event on global warming or on global climate change, but more severe weather is predicted. And what we're seeing is increased droughts, increased wildfires, increased flooding, stronger hurricanes, and other extreme weather events. If we just look at this summer alone, you probably heard about the extreme heat in the Pacific Northwest, reached 116 in Portland and 108 in Seattle. If you've ever been up to that part of the country, you know that that is shockingly unusual. But up in British Columbia, it set a new record for the country of Canada. It got to 121. You know, that's the kind of temperatures we expect to see somewhere like Death Valley or in some desert in some other part of the world, but not in British Columbia. Also, wildfires. Right now, this is a headline at the top from yesterday. 80 large wildfires have consumed more than 1 million acres across the western parts of the US. And we are just at the beginning of the fire season. This is a very serious situation. And you've also probably heard about, down at the bottom, Hoover Dam's Lake Mead hits its lowest level since the 1930s. That lake was built in the 30s, and then it filled up, and it's now at 36% capacity, and that's going to be a crisis for some parts of the western US that depend on that lake for both water and electricity. And you've all been hearing about the recent flooding in Germany. So, and a lot of the scientists there think that based on various models, climate models, that human disruption in the climate system is making the extreme weather even worse than predicted. It's just fairly dramatic. They haven't seen anything like this in Germany to this scale, to this destruction. And we see things like this happening in other parts of the world. If we go to the Arctic, for example, and I've spent a lot of time in the Arctic, the amount of sea ice, and you have to compare month to month because the sea ice in the Arctic changes during the year. And this is what we see with the average monthly sea ice in the Arctic in the time frame beginning somewhere around 1980 and ending up, I think the last year on this is 2018. So there's been a steady decrease in the amount of ice in the Arctic. Here, for example, is a diagram showing the Arctic sea ice boundary in the summer in 1979, and you can see where the sea ice is in a more recent year. That's a pretty dramatic difference. And in fact, I was able to be on a small expedition that we flew up to the Arctic Ocean on the coast of Canada, and we were able to go all through what is called the Northwest Passage and get over to Greenland. And I did that several years ago, and that was something that would have been literally impossible in the relatively recent past. Another thing that we're not totally clear about yet, but I think a few of you guys may have had a little cold weather this winter. I know up here in Sherman, we did. We call it the snowpocalypse, and there are various names for it. Some atmospheric scientists think this is the result of what is called the polar vortex shifting. So the polar vortex is a circular air movement pattern over the pole. And because the Arctic is being destabilized, because it's getting warmer and warmer, that is affecting the jet stream, and the jet stream is no longer keeping the polar vortex up over the pole. And so the polar vortex sometimes slips and comes down, bringing a massive amount of cold air with it. And so what we saw all the way down here in Texas was very low temperatures for an extended period, and that caused a tremendous amount of damage. And you can see, for example, here, polar vortex could bring frigid temperatures as far south as Texas. This has now been making it onto national news services, and you can see the jet stream is not where it should be, it's way down. So this is another example of these kinds of extreme weather events, and these things affect plants and they affect animals. A lot of animals died as a result of this. You may have seen, I saw one or two birds in my yard after that. Some birds weren't able to stand the cold. It certainly affected many plants. Many of the non-native plants were seriously damaged. So I want to mention a little bit of personal observation, because I became more and more interested in this over the past 10 years and decided that I actually wanted to go to some of these places and see for myself how things are changing. And so I've been to both the Arctic and the Antarctic, and I've been to the Arctic many times, and I'll show you some slides that give you some information of things that I've actually seen and experienced. So I was up in Glacier Bay in Alaska in 2019, and at that time, and this is a glacier there that I've been to a number of times, and it keeps retreating. And more than 99% of glaciers in Alaska are retreating. In other words, they're shrinking. They're melting at the front, and they're much shorter now than they used to be. And this is happening all over the world. I've actually been to glaciers on most of the continents, and we see this everywhere. Now, people who say that global warming isn't real will say, well, there are a few glaciers in Alaska that are growing. That's true. There are something like 1% of glaciers in Alaska are growing, and that's because the weather pattern has shifted so much that there is, instead of less snow in a few places, because of the way the mountains are arranged, there's a lot of snow that's falling on a very, very few glaciers, but the vast majority of glaciers are shrinking. Now, I didn't take these pictures, but I've been to this glacier area in Argentina, and I'm showing you two pictures to give you a sense of what's happened. I love these paired photographs that were taken decades apart. This is the Uppsala Glacier in southern Argentina in what's called Patagonia, and that's 1928. And this is the same place in 2004. You can see that this glacier was all the way down to the front of the picture. And you can see the same three mountain peaks in the background. And in 2004, it was dramatically different. And of course, it's continued to melt since then. I've spent quite a bit of time on the island of Iceland. It's right up at the Arctic Circle, and there are a number of volcanoes there, very tall volcanoes that are covered with ice caps, and it's a fascinating place. I highly recommend it. This is about 3 years ago. My brother and I were there, and we hiked up to some of the glaciers, and the glaciers there are shrinking. It's pretty dramatic. You can see this glacier does not look healthy. It's melting. You can see dust that's accumulated. It's unfortunate. The Arctic is the most rapidly warming place on Earth. And that's not to say it's not still cold. This is from a trip I was on a few years ago, and we were at a Inuit village on the coast of Greenland. We were the last folks to be able to get into that village before everything froze up for the winter. We came in these Zodiacs. It's still cold, but it's not as cold as it used to be. So this is it's a spectacular place, but it is warming. Now, from going to these places, I see the same thing happening all over the Earth, whether it's from Antarctica or somewhere Alaska or in Iceland or even further north. We see the same thing. The climate is changing. And I would just like to ask, what do unbiased scientists think? Now, those are people with nothing to gain or lose. What do they think based on the evidence? Okay, I have nothing to gain or lose by telling you anything. I'm a retired college professor. I actually still teach one course, but I don't depend on my work to support me. I'm retired. Nobody, and I have no interest in people paying me to say something. I'm pretty unbiased. I'm trying to figure out what is happening. And my colleagues at the college, I have one colleague who's an atmospheric scientist. I have another one who's an environmental expert. I have a chemist friend who is an expert in these kinds of things as well. We are unanimous in assessing the evidence that this is real and that humans are driving this process. And if you actually look at it, something like 97%, based on a study, 97% of scientists agree. That's pretty amazing that you can get 97% of experts in any field to agree on anything. Now, that you can find scientists who will disagree. But here's the thing. You could find scientists and doctors and lawyers who would disagree that smoking is harmful. You can find people who will, the fact of the matter is, give people money and you can get people to say virtually anything. But it's pretty dramatic how much unanimity there is right now. So let's shift over to some of the biological effects of climate change. And I want to look at the effects on phenology. That's a word that we use. It means timing. Things like, when do plants leaf out? When do they flower? When do they make their fruits? And what are the implications for Texas? So this is another paired photograph, and I love this one. This one is not in Texas. This one's in Massachusetts. And on the left, this is 1868 on Memorial Day. Now, Memorial Day started as a observance for Civil War soldiers. And so you can see here, the trees had not leafed out. This is Memorial Day in 2005. And it's the same place. I think you can convince yourself that's this thing, one of these statues, and the other two are hidden by this bush. The road looks a little different. This was a dirt road then, and it's been paved, so it's covered up a couple of the steps. We see things are changing. And we're seeing the implications in Texas. Since I've moved here, I came to Texas in 1981, and there's been a rather dramatic shift in plant hardiness zones. So the two best graphics I could find, one was from 90 and one was from 2015. And if you look at the zones, this is what the FDA, for example, says about, this is what the agriculture people say you can plant your plants. And if you look at this, back in 1990, up here in northern Texas, where I live, we were in zone 7. Now we're in zone 8. Pretty dramatic shift. You can grow things here you could not grow before. Now, the snowpocalypse may have changed a few of those, but that's not unexpected. This is another thing that's interesting. And I'm going to focus mainly on plants as we go forward, but animals have been affected too. I used to spend lots and lots of time in Mexico. I did my PhD research studying plants in remote areas of Mexico, looking for new species. And I got to know a bird called the crested caracara that was very common. This is a raptor-like bird, looks a little bit like a bald eagle, but not very much, in fact, once you look closely. And this is where, on this map, you can see caracaras are supposed to get in the northern, how far north they're supposed to get in Texas. Now we see them up here. I'm in Grayson County up on the Red River. Now we see them up here. I've seen them many, many times. They have migrated north. That's what we expect. We're seeing other animals migrating north. They're not constrained as much by temperature as they were in the past. And more than 70 species of South Texas birds, for example, have now been known to range north and east. And a lot of scientists think this is due to climate change. We're seeing effects on migration patterns of birds and butterflies and other creatures. Now, monarchs, many of you are familiar with. Some estimates are that the population has declined 95% in the last 20 years. I don't know if that's true. The fall migration has been delayed in recent years by warmer than normal temperatures. And unfortunately, if their departure from further north is delayed, then they get caught in the cold when they get further south often. And we think more extreme weather events are affecting the monarchs. We think some other things are affecting monarchs as well. Some of you are probably very familiar with some of those other factors, like certain types of pesticides. There's also what we call the loss of synchrony between pollinators and their host plants. There's not as much research been in the US on this. There's more been done in some other places, particularly in Europe. But this is an interesting example of a 2018 study. The sharp rise in spring temperatures in Austria makes the butterflies emerge from their cocoons several weeks before their host plants have any nectar or pollen to offer. So in other words, the butterflies are coming out, they're ready to feed, but the plants aren't flowering yet. And we're afraid that this kind of loss of synchrony is going to affect other plant pollinator interactions as well. And when that happens, you can see a decline in the populations of those creatures. Now, there's both winners and losers when you have climate change. And one of the winners are bark beetles. Bark beetles are these small insects that drill into trees, feed on the nutritious inner bark, and they're particularly hard on conifers, for example, pines, but other kinds of things as well. And bark beetle damage is now widespread in the US. They even affected, my family has some land in Virginia, and the bark beetles several years ago killed quite a few pines there, but this is happening all in the western US. It's happening up into Alaska. And this, of course, is a big deal because as fires become more prevalent, dead trees burn even easier than live ones. And so this is like a double whammy for some of the parks, but of course the forests in the western US. So we know quite a bit about this. The southern pine bark beetle is limited by 14-degree winter temperature, but that temperature line has moved further and further north. About every decade, that line has moved 40 miles further north. So these southern pine bark beetles are damaging trees further north. So the warmer winters and warmer summers, the warmer winters mean more beetles. That gives us more dead trees, and the warmer summers gives us more wildfires, and that's a real problem. So when we have warmer climate, plants can react in a couple of ways. Now, plants can't move, individual plants can't move, but they can migrate because their seeds can be moved. And so if plants have enough time, they can migrate up mountains, or they can migrate, if it's getting hotter, towards the poles. And obviously this is what happened during the various ice ages, that plants were able to migrate further north and then migrate further south. Unfortunately, though, now that's not so easy because humans have disrupted the landscape. Plants aren't going to be able to migrate if there's nowhere for them to go, if there are cities and farmland in the way. And things are happening so quickly that we don't think plants have time to migrate anyway. But that's a big deal. We know plants have migrated in the past. What was Texas like 18,000 years ago? Now, keep in mind that the glaciers came down to about 40 degrees. That was ice down into the Ohio River Valley at about 18,000 years ago. And so Texas's climate was very different at that time. And we know that, for example, I'll just give you one example, a tree, the white spruce, that decay occurs up here, just barely gets down into the northern US. We have good evidence of pollen of white spruce from bog cores down in central Texas. So there's pollen that has been recovered when scientists study certain bogs in central Texas, south of where you guys are. We find that the climate was very different, and we find different species back thousands of years ago. So we know that plants have moved. What's going to happen in the future? Well, we don't know. Here are the predictions. Texas is one of the most vulnerable states when it comes to climate change. More extreme weather is predicted, increased droughts and wildfires and flooding. Summers are likely to become increasingly hot and dry. Soil moisture is likely to be decreased, and arid areas of the state likely to become drier and risk desertification. And we're likely to see sea level rise. Coastal areas can be affected. All of these things affect native plants. And it's kind of interesting when you look at energy-related carbon dioxide emissions by state. I was able to find this graphic. It was from 2016. Texas is the champion emitter of carbon dioxide in the US. So maybe somebody could say that's karma, that Texas is one of the most vulnerable states. I personally hope that we're all wrong about climate change and it doesn't happen, but as a scientist, the evidence to me is astonishingly compelling. But compared to many states, we just produce a huge amount of carbon dioxide. So let's look specifically at some Texas native plants and animals. And here are a few of some of my favorites. Some of you may grow the Hinckley columbine, for example, in your in your native plant gardens. But here's a Texas native plant, the red mangrove. And this is an important coastal plant. It appears to be moving up the Texas coast. It's typically found in tropical regions, and it's now found more than 200 miles north of where it was on the earlier maps. The mangroves are moving north. It's warmer, and so mangroves are able to move north because of this warmth. Now that has benefited the mangroves. But I would say some of these things are like the canary in the coal mine. I use this analogy as an early warning system. I call these things ecological indicators. You may remember coal miners used to take little birds down into mines because the birds are more sensitive to toxic gases. And if the bird collapsed, that warned the miners you had to get out of there as soon as possible. So some of these plants maybe are serving as ecological indicators. So let's look at a few of these that I think we can look at, and if we start to see changes in these, that's going to tell us something. There's a wonderful clematis called the scarlet leatherflower, Clematis texensis. It's a red one. It only occurs in central Texas. If we see that beginning to be lost, that would be an ecological indicator, a canary in the coal mine. It's nowhere else on earth does this occur in the wild. It's endemic to Texas. Here's another one, big red sage. It's endemic to this part of the state of Texas. The only place on the planet where it's wild, grows wild. It's been brought into cultivation, but it's not wild anywhere else. How about what's going to happen to some of our other native species? I really like some of these weird distribution patterns. So this is witch hazel, and witch hazel is a plant that does well in humid places. So it grows in Texas over here on the Louisiana border, but there are a couple of spots over here in the hill country down in river bottoms, in ravines. And these are hanging on from glacial times. So we would predict that they might be lost because this area is getting much hotter and drier. Here's American beech. This plant really doesn't, it's a beautiful tree. It's got smooth bark. It's a beautiful tree in the oak family. It's very, very common further east. I grew up with it on our farm in Virginia. It only occurs over here in Texas, and it doesn't do well here because it's just too hot for it. But if our predictions hold in a few decades, we may lose American beech from Texas. And if we lose American beech, we will also lose beech drops. This is one of those weird and fascinating little plants. That's another Ice Age holdover in Texas. This is a parasite. It has no chlorophyll, and it grows on the roots of the beech tree. So this is a parasite on the beech tree called beech drops. And the only thing that you see of this plant is when these little flowering stalks shoot up. Otherwise, it's down inside the beech root. If the beech goes extinct in Texas, we'll lose beech drops as well. And we have some other of these Ice Age holdovers that are only growing in a few counties in the wettest part of East Texas. There are three that I think are particularly interesting and pretty. This beautiful Carolina lily. This is bloodroot. By the way, it's called bloodroot because the root, actually it's a rhizome, is just blood red. And this is a quote from an article, hanging on precariously to the older geological terraces in the coolest locations in the forest. And this third one, the yellow trout lily, you can see we only have this from 3 counties in Texas. I think this is a beautiful plant. These leaves are fantastic, that modeling of the color. But this is one of these ecological indicators that I'm afraid we probably will lose. Now, my last few plants to mention are growing on what I call sky islands. And these are tiny islands of mountain peaks separated by vast oceans of inhospitable desert or dry habitat. So if you go out to West Texas, go out to the Chisos and Big Bend, or if you go out to Guadalupe Peak, these are sky islands. And they are remarkably rich in terms of plants. You might not believe this, but far West Texas has more species of ferns and their relatives than does East Texas. And they're growing up on the small populations, but they're growing up on these mountain peaks. Many of them are tropical things that this is the furthest north. They're really Mexican plants, but they get up into these sky islands. Now, I'm talking about these because I find it fascinating, and I think these are going to be some more of our ecological indicators, our canaries in the coal mine. So all of you probably familiar with Chisos Mountains, where Big Bend is, the Davis Mountains, where the big observatory is at, and of course, Guadalupe Peak, the highest spot in the state. And these are similar to the Sierra Madre of Mexico. And so you've got rare habitats and small populations, and they're very vulnerable. Because remember I said plants can move up mountains? Well, these plants are at the top already. There's nowhere for them to go as it gets hotter. So here's a place called Boot Springs in the Chisos Mountains. Some of you may have hiked along there. Looks like an upside down cowboy boot. And this is a fern, the Chisos holly fern. In the whole country, it's known only from the Chisos Mountains. And if it gets too hot for it there, we'll lose it from the United States. The Davis Mountains, I imagine most of y'all are familiar with this observatory. Davis Mountains have lots of interesting plants. Here's one called the Heartleaf Cliff Break. It's only known in the US from two mountains, two of these peaks, the Davis Mountains and the Chisos Mountains. This one, many of you have in your wildflower garden, I bet. It's widely planted now in Texas. It's Hinckley Columbine. It's only known from 3 mountain ranges in Texas and then in adjacent New Mexico. So Sierra Vieja Mountains, Guadalupe Peak, and the Sacramento Mountains. And the Guadalupe Mountains, of course. This is one that's a fascinating little example. This is a beautiful endemic yellow violet. This is only known from one place on the planet. It's known from about 8,000 feet in the Guadalupe Mountains. And if it is no longer able to grow there, it's not going to grow wild anywhere else on Earth. Now, this is going in the future, I think, to challenge our way of thinking. What does native mean? Right now, if you say that something is a Texas native, and I grow native plants, a lot of them in my garden, if it's native, that means it grows wild somewhere in Texas. But in the future, native species from other areas may become our new natives because they're the things that are going to be able to grow here. And many things that are currently native here may only survive further north or east. And so we're going to have to be flexible over the decades, I think, not necessarily us, but future people interested in native plants and animals. They're going to have to change how they think about native because some of the things that are native now simply will not be able to survive here anymore. And things that are now native elsewhere won't be able to survive in those places. And so we're going to have to be somewhat flexible. Now, I don't want to leave you kind of with a bummer, with a down, kind of an unpleasant thought, because I'm hopeful change can be quick. And there was an article a few years ago, and I like this quote, but as history shows us with regard to other shifts and norms, once the ball starts rolling, momentum can build and remarkable change can take place. And I'm 69 years old, and you know, I've seen things change a lot in the U.S. Um, I was not born when this occurred. I was born in 1952. But in 1948, an air pollution event killed 20 people in Durant, Pennsylvania, and sickened 7,000 more. Pollution used to be horrible in the US. The Cuyahoga River in Ohio burned twice, once in 54 and once in 69. I actually remember this. There was so much petroleum pollution on the Cuyahoga River that it actually, so much basically oil floating on the river, that it caught fire and burned. There were so many of these things happening that there was public outcry, and this resulted in environmental protections, and the result was the formation of the Environmental Protection Agency. And my brother worked for the Environmental Protection Agency for 34 years. And I was in China about 11 years ago, and you can hardly believe the pollution in China. These people were not wearing masks. This is many years ago. These people were not wearing masks because of COVID. This is because of pollution. You can't believe how bad the pollution was. And I told my brother when I got back, I said, if people spent any time in China, they would come back and bow down and give thanks in front of the building where the Environmental Protection Agency is at. So I'm going to stop there. I want to leave several minutes for questions or comments. So I'm going to stop the screen share. And I think, Betty, are you going to ask questions from the chat, or Candy, you're going to do that?
Candy is.
Okay, thanks, Candy.
You need to unmute Candy.
Great. Oh, hopefully you can hear me, and I hope you're okay with my calling you George.
Please.
That's your name, and I'm Candy. Okay, great. We have only a couple of questions, but I'm sure that if y'all can think of anything else, please go ahead and write them down now. One was, which agricultural growth zone in North America have shrunk the most since 1990? I don't know if you would know that.
You know,
I have an idea.
I don't know, and since I make a point of not answering things that I don't, I don't know, and I can't tell you because it's complicated, because the line of agricultural zones is not straight. It's not like everything is moving lockstep to the north. So sorry, I can't give any definitive answer on that.
Okay, well, also Steve asked, it seems that climate change issue has become very political. Are you aware of any credible evidence that either climate change is not occurring or that the cause is not man-made?
I personally don't know of any credible evidence. I think it's unfortunate whenever a scientific matter becomes politicized, because people then can no longer look at the evidence. They have to go along with their group. And I think that's unfortunate. But I have tried to look at lots of the arguments against climate change. And what I often find is that, not in every case, and I want to emphasize this, there are some people who are honest scientists who feel, based on the evidence that they look at, that there are questions. And scientists should always question our conclusion. But I find that many of the people who are most vociferous against climate change have either a money or a political dog in the fight. And I often tell my students, whatever matter it is, and I teach public health now in my retirement, and there's a lot of stuff in public health involving various pharmaceuticals. And I tell my students, follow the money, whether it's medicine, whether it's climate change, it doesn't matter what it is. You have to be careful. You have to assess the source that you're talking to, that you're getting information from, based on, do they have a financial or some other interest that will bias them, because scientists have to work very hard to not to be biased, to try to look. And, this is something we have to be real careful about because we can fool ourselves. So, Steve, it's a good question. I can't find what I consider to be solid, rational, convincing arguments that either climate is not changing or that humans are not causing it.
Okay, thank you. And we also have a question. Why is Texas the highest CO2 emitter in the United States?
That's a good question too. I think there are a couple of reasons. In fact, there are probably many reasons. First, Texas is big, so we're a large state. We're not the largest. I don't know the exact number of people in Texas versus California, but Texas is way ahead of California. So it's not simply either geographic area or number of people, but we also have we have a huge highway network. So there's a lot of driving in Texas. We have a lot of oil refining in Texas, that massive area down along the Gulf Coast. We have a lot of oil production and, like the Barnett Shale, and a lot of gas production. And so CO2 is being released in that way. So there's not one reason, but there are multiple reasons. But when you put it all together, Texas has really been a very strong producer.
Mm-hmm. Well, George mentioned that he finds the growth in wineries in the Fredericksburg area interesting. Given the rate of warming, it seems like a long-term kind of iffy investment.
That's interesting, and I'm not enough of a viticulturalist to say. I know that some of their grapes they import, and then the wineries use them, but also irrigation can do a lot. And so I don't know. I think George, is that who you said that? I think
George.
that he's thinking, I think that's a very rational way to think, because wine industries all across the planet are being affected. Things that where wine used to be grown in southern parts of Europe, that's no longer as good for certain varieties of grapes. And so wine production in Europe is moving to the north. And we see the same thing over on the Pacific side of the US. There's a brighter future in the Pacific Northwest for the wineries, I think, down rather than in Southern California. So I would agree with George's basic comment, not just because he has the same name.
Okay, well, good. I'm glad that wasn't it. And here's on kind of a grander scale, can the orbital patterns of the planets cause some of these climate changes?
Absolutely. There's all kinds of stuff that can have effects on climate. Tremendous number of things. And we see that because we know the Earth's climate has been affected by the glacial cycle, for instance. Earth's climate has seesawed tremendously over the past few million years, from tremendous times of tremendous cold to times of tremendous heat. But what we're seeing now is something that's going in the opposite direction of what we'd expect. We would expect, if anything, to be witnessing maybe the beginning of cooling, and we're seeing a dramatic increase in temperature. So I definitely agree that there are, we're not talking about just planetary, we're talking about solar system effects and beyond, in fact. So there are huge, large scale effects that affect climate. But the way things are changing now and the rate at which things are changing, we think that's not what's going on. The best evidence is that this is driven by something else. Because we know the gases in the atmosphere affect the temperature of the planet. We wouldn't even be able to live on Earth if we didn't have the greenhouse effect. because Earth would be too cold. We simply wouldn't survive. So we should all be thankful there's a greenhouse effect, because that's what makes the Earth habitable. It's just too much of a good thing right now.
I understand what you're saying. And actually, Dee was asking if there are any particular plans that you can think of that have promise on slowing or reducing climate change.
This question is very good. I can't think of any particular plants, but I think
Plans,
Oh.
just plans as opposed to.
PLANS.
Yes,
Oh,
yeah. Can you think of any particular plans that you think have promise?
there are a number of what are called geoengineering ideas. I don't know if we'd say they're developed to the point of plans yet. Geoengineering ideas to block sunlight or do something like that. I'm a big believer in the concept of unanticipated consequences. So we've gotten ourselves in a spot on Earth where we're putting out so much CO2, temperatures going up so rapidly that we're almost desperate. We may be desperate enough to try some of these things on a planetary scale. For example, throwing large amounts of sun-blocking stuff up into the atmosphere. What if we don't know as much as we think we know? We're all living here. We don't, and we're not going to get on a rocket and go to Mars. I don't care what they tell you. You know, we might send a handful of people to Mars, but none of us are going to Mars. You can take that to the bank. So, do we want to take a chance and do something this extreme? I don't know. I'm a big believer in the insurance model. It will cost us something to not put out as much CO2. But all of us have insurance on our houses, right? Now, you hope you're never going to use that. I'll just tell you that my wife and I just had a dramatic example of this. Lightning struck our house and burned it in April, late April. And fortunately, we had a little house up in the country where I'm sitting in now, and now that's where we live.
Oh my.
I'm glad we had insurance. Should we take out a little climate insurance and not put out as much CO2, have a small economic decrease now and not risk it? Are we 100% sure that climate is changing and we're the cause? No. Scientists are never 100% sure of anything. But I'm telling you, insurance, I bet each and every one of you, if you own a house, you have insurance. And I hope you never have to use it.
Exactly. We're going to take one more question. Betty has one. She's asking, how does generalized warming generate more extreme weather events?
Betty, that's a great question. And there are multiple ways I could answer that. And I'm not an expert, but in that part of it. But when the example I gave you of the movement of the polar vortex is one example. Because it's gotten so warm in the Arctic, the jet stream is no longer as stable as it once was. And so that means that big masses of cold air can move where they would normally not move. There are other things. The temperature is not just affecting the atmosphere, it's also affecting the ocean. And so this is actually changing ocean currents. And there are many parts of the world that would not be the way they are now if it was not for certain currents. So for example, the country of Iceland, which I've spent a lot of time in, Iceland would not be nobody's to say Iceland is a tropical paradise, but Iceland has, it's a very livable place if you like kind of cold, wet environments. But it's as warm as it is because of the Gulf Stream going up there. And the same thing can be said about the British Isles. The British Isles would not be the way they are today if it wasn't for the Gulf Stream. If you actually compare where London is, where that compares with something like Chicago, you know, London is really far north, but London rarely has real cold weather. It's often in the winter there, it's cold and wet, but not cold and icy. It can snow in London, obviously, but it's usually not real cold. So when you change ocean currents, that shifts things as well. And also, I'll give you one more example, say with storms. As ocean temperatures increase, that causes hurricanes to gain energy faster. And so we don't think climate change is affecting the number of hurricanes. We think it's affecting the intensity of hurricanes because the storms are able to pull more energy because the water is hotter. They pull more energy out of the water, and that gives them more force. And so instead of, you know, maybe a, what do they call it, an F3 or whatever, when it hits the coast, now it may be a category 4 or a category 5 hurricane. So that's just a little bit, but that's a complicated, very, very complicated question. And I don't know too much detail about it. So thank you. Thank you for all those questions. I appreciate it.
George, we certainly appreciate your presentation. It was just fantastic and gave us so much information in a way that we can understand. So
Well,
thank you very much.
it's a pleasure to be with you guys, and good luck with all your nature work.
Thank you so much, George.
Bye-bye.